Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series called War Stories. In this week's show, we learn that you may not necessarily always be able to trust one of the most common web tests, namely tensile strength. I know your time is precious, so let's get started. Recall that a war story is a memorable personal experience that we might learn from. We are guided by the saying that the smart person learns from their own mistakes, but the wise person learns from the mistakes of others. In this lab test story, we learn three things. First is that you shouldn't necessarily always trust instruments. If you do, you will eventually get disappointed, if not burned. Second, this trust can be broken even with the most common brand of the most common web test. Third, even standardized tests are not immune from misbehavior. MD strip tensile strength is the most common web test after basis weight and thickness. There are many standards prescribing how to do this testing. See Chapter 2 and Appendix T of the Web Handling Handbook for details. There are also other material properties that can be obtained from the same machine by reconfiguring the software. I am sure that everyone has seen this test, perhaps hundreds or even thousands of times. The strip tensile specimen first elongates, then necks, then breaks. If it breaks at the clamp, most standards require retesting a new specimen. I always let operators run their machines because they know them best and can run them most efficiently and safely. For similar reasons, I let test technicians run their test instruments. One good reason is that the gauge R&R variability of a test technician is generally far less than the variability of an engineer because they do it every day. So I usually watch the work politely and thankfully. This can be repetitive and thus boring. However, rather than allowing myself to be bored, I start to pay attention. I saw something with this test that shocked me. Can you see anything wrong? Look closer. Look closer still at the area in the circle near the clamp. Have you figured out my concern? The answer does require a bit of understanding of physics, or mechanics to be more specific. Because I was a finite element modeler in a previous life, I know what the rules are for boundary conditions at an interface, such as a clamp. The proper clamp that is fixed in all directions except for the pull direction will cause the specimen to always do two things. The first is that it must preserve width. The second is that the edge of the specimen must depart straight. However, this clamp did not do either. The necking of the specimen was not just outside the clamp, it was also necking inside the clamp. Does this help give you an idea of what the problem might be? To check my suspicions of slippage inside the clamp, I drew a line on the specimen at its boundary with the clamp prior to the pull. After the pull, it was easy to see the specimen pulling away from the clamp and that slippage was worse at the edges. To make a long story short, as all good storytellers should, I dug a little deeper and found that the clamp faces were warped. They had a convex shape so that the edge of the specimens were not clamped as well or at all with very thin webs. All of them. Every clamp from a name brand tensile testing machine supplier. the consequences of warped clamps could be quite serious. First, the ultimate strain data, often called stretch, would be essentially worthless if there were slippage. Second, it is possible that the strength data may also be compromised. There were a dozen labs in one large company using just such clamps. Of course, this story is not just about clamps or tensile strengths per se. It again is a cautionary tale about trusting instruments, even from premier manufacturers, and even if the test is also standardized. But I think the bigger lessons are to not just run test recipes and record numbers like a robot. Pay attention to the details and ask questions if you don't understand what it is that you are seeing. I hope you have enjoyed this gripping tale. Stay tuned for next week's show, where I will talk about how a mentor taught me how and why it is necessary to always check computer models. If you have a topic you would like to hear about, let me know in the comment section below. If you found any of these stories to be interesting or useful, please like and share and subscribe. See you next time.